We continue Unit 16, Solving Exponential Equations with Unlike Bases. To solve exponentials with unlike bases, we need to rewrite both sides of the equation using the same base. Then set the exponents equal and solve. First example. 2 to the x power is equal to 32. Look at the very first number here. It is a 2. And I can ask myself, can I rewrite 32 with the base of 2? Well, 2 raised to the 5th power is 32. Now, both of these bases are the same. So set the exponents equal to each other and solve. And x is equal to 5. Example 2. Looking at this expression, I have 2 to the x equals 1 over 8. I need to have the same basis. 2 is already broken down as far as it will go. So look at 8. I can rewrite 8 to be 1 over 2 to the 3rd power. I still do not have the same base because 2 and 1/2 are not the same base. Now we need to rewrite 1 over 2 to the 3rd so that it is the same base as this 2 right here. So I am going to bring this 3 to the top, and it will be 2 to the negative 3 power. Now that our bases are equal, we set the exponents equal to each other and solve. And x is equal to negative 3. Example 3. I need to get the same base. I have a 4 on this base. Can I rewrite 64 to have the same base as 4? Well, 4 to the 3rd power is 64. So I'm going to leave this alone. 4 to the 2x minus 1 is equal to 4 to the 3rd. Now the bases are the same. So we rewrite and set the exponents equal to each other and solve for x. Add 1 to both sides, and 2x is equal to 4. Dividing by 2, x is equal to 2. Example 4. In this problem, when I look at the smaller base, I see that I cannot raise that smaller base to a power to get 27. 9 squared is 81. That won't work. So look at 9 again and try to break it down into its factors. Its factors are 1, 3, and 9. 9 didn't work. We wouldn't try 1. Look at 3. Can I break 27 to be 3 to some power to get 27? Yes, I can. 3 to the 3rd power is 27. Since I couldn't break this one to be 9 to some power, that means I will need to rewrite this first part, or this first term, as well. 9 is 3 squared. And that is raised to the x plus 1. Now that I've taken care of getting the same base, I need to follow my laws of exponents. This is a power raised to a power, so I need to multiply the powers. So we have 3. 2 times x is 2x, and 2 times 1 is 2, and that's equal to 3 to the 3rd power. I have one base that is the same on both sides, So now we just set the exponents equal to each other and solve. Subtract 2 from both sides and get 2x is equal to 1. And then divide both sides by 2. X is equal to 1/2. Example 5. 2 is as small as I can break this base down, so I'm hoping that I can change this 4 to be a 2 raised to some power. And it is. 4 is the same thing as 2 squared. And I still have 2x plus 3 that needs to be multiplied by it. Now I have the same basis. However, I need to follow the rules of exponents. It says when we have powers raised to a power, we multiply those powers. 2 to the x minus 1 is equal to 2. 2 times 2x is 4x. 2 times 3 is 6. Our bases are now the same, so we set our exponents equal to each other and solve for x. Subtract x from both sides. Get negative 1 is equal to 3x plus 6. Subtract 6 from both sides. And 3x is equal to negative 7. I still need to divide by 3, and x is equal to negative 7 over 3. And there's my answer. This concludes the second flap of our foldable.